All right, here we go. Hey, so on Friday, we talked about, like, you guys watched the video, and I know it's not great, like, watching a video of me teaching. It's better when a teacher is here actually teaching you guys this stuff. But sometimes that's the case where, you know, if I'm absent or something like that, I can foresee me doing more of that where I record a video on a lesson and, you know, show it to you guys so you can learn something. I also thought it was a pretty elementary topic, like identifying triangles based on sides and angles. You guys have done a decent amount of that in the past, I believe. So I thought that would be a pretty easy concept for you guys to grasp on, okay? All right, quick recap. What do we call a triangle that has no congruent sides? Scalene. What do we call a triangle with two congruent sides? Isosceles, and then if they're all the same, equilateral. Very good.
What's the equal angle here?
What does it mean if a triangle is equiangular?
All the angles are equal.
All the angles are equal, and all of the angles would have to equal what?
180.
Well, so all three of the angles add up to 180, right? But if it's equiangular, all three angles
60.
would be 60, right? Because 180 divided by 3. Okay, very good. All right, what do we call it if a triangle has a 90-degree angle? Right triangle. What about if all the angles are less than 90? Acute. What about if one's bigger than 90? Obtuse. And you can't have more than one angle that is bigger than 90 because then the sum would exceed 180, which we cannot have, okay? All right, Parker, stop doing whatever that is. Thank you. Okay, so then we talked about classifying triangles based on sides and then based on angles as well too. So it was predominantly what the front of the worksheet was. The back, you had to classify them, but they just gave you coordinates. So you had to use distance formula, like Molly's going to show us here in a minute, in order to...
I didn't use distance formula. I didn't do number 10.
Got it. No problem. I will happily do it here in a minute. Let's talk about number 1. So number 1 is on the backboard up there. It's also up here. Who put number 1 up there? What is it, Kalia? Good. So it's an isosceles triangle because 2 of the sides are the same length, because 2 of the sides are 2.5. And then it's obtuse because 1 of the angles is bigger than 90. Perfect. All right, what about number 2? We did number 2. All right, Mallory. What'd you say it was?
A right triangle and scaling.
Good. So a scalene right triangle or a right scalene triangle, whatever. It's right because one of the angles is 90. It's scalene because none of the side lengths are the same. None of the angles are the same, which implies that none of the side lengths are the same as well. Okay? All right, number 3. Raph, you did number 3, right? What'd you find out about number 3? What is that? Good. All the angles are less than 90. And then based on its sides, it would be scalene. None of the sides are the same. What about number 4? Who did number 4?
Me.
All right, birthday. What'd you find out?
It's acute, it's an equilateral.
Yeah, all the angles are less than 90, but we can also say something more specific about the angles. Okay, help them out, Jillian.
I erased it because I thought it was wrong. Equal angle here.
Equiangular. Good. Good. Since all 3 angles are the same, it's equiangular as well.
Oh, okay.
Okay. All right, and then let's do sketches for 5 and 6. Jillian, you did those where? Over here? Okay. So for 5, that's not what I wanted to do. I wanted to do this. Okay, so for 5, we want to draw an obtuse scalene triangle. So as I'm looking at Jillian's, it's obtuse because one of the angles is bigger than 90. And then it's scalene because none of the side lengths are the same length and none of the angles are the same length as well too. So this is a perfect obtuse scalene triangle. And then acute scalene, all the angles would be less than 90. That looks really good to me. And then all 3 of the sides would be not the same length. So 3, 2.1, and then 7.3 is good. Now, I don't think I said this in class, so let me say it now. Across from your biggest angle, or the side that's opposite of your biggest angle, will be your biggest side length. So if one of them was 7.3, it would be this one here, because that would be across from 67. And then across from your smallest angle would be your smallest side length. So across from 56 would be your smallest side length of 2.1. And then across from 57, your most middlest side length would go, your most middlest angle measure would go your most middlest side length, which would be
I don't understand that.
3. Well, let's look at this. So like in this picture right here for number 1. So Kalia drew it on the board back here. But if we look at here, my biggest angle in there is 128. The side length that is opposite or across from 128, 4.5.
So that's the biggest one.
It's the biggest one. It's got to be. And then you'll notice that the side lengths that are across from my other 2 angles, those 2 angles are the same measure, right? Across from those, I have, so across from this angle here is 2.5. And then across from this angle here is also 2.5. So since those are the same angle measure, the side lengths opposite them should be the same side length as well too. And then like over here in number 2, this one's missing a side length, but across from 90 would be 13.2, which is my biggest of the ones that are there. And then across from 58 would be 11.2, smaller than 13.2. Now, they didn't give me a value here. If I were to estimate one though, 32 degrees is my smallest angle that's there. So the side length from there would have to be opposite 11.2. So something small or something less than 11.2. So I don't know, 7, 8, whatever. But that's, if there was a picture there that was full, then we could figure that out. Or like for 4, all those angles are the same length or same measure. All 3 of the side lengths are the same measure as well too, because all 3 of the angles are the same. Okay. All right. 7. Okay, so Emma, you did number 7 for us over here. So with 7, it says that the triangle is equilateral, meaning all 3 of the sides are the same. So you need to solve for x. So you just pick 2 of the sides and then set them equal to each other, right? Because it's equilateral, all the sides are the same. So then x plus 5 equals 3x minus 9. Solve for x and got x equals 7. And then it goes on to say find the measure of each one of those sides. So you took that value, and I love how you organized your work here, but you just plug 7 in for x in each one of those situations and then got each side length as 12. So great job, Emma. Kind of stole your thunder there. I feel bad about that. Molly, you did 8.
Yeah.
All right, I'm not going to steal your thunder. I feel bad. I stole all of Emma's. So with 8, it says that the triangle is isosceles. What's that mean?
It means that 2 of the sides are the same.
It does. So we have to be careful because they give you 3 side lengths, right? But they don't say which 2 of the side lengths are the same. So it might help if you draw a picture and say, okay, here's my triangle. It says that L is the vertex angle. That is the angle that is not congruent to the other one. So we can say that L is up here, M is here, N is here. And then it goes on to say LM, so these would be the angles that are congruent, or these would be the sides that are congruent. So LM is 3x minus 2. And then my other side length is going to be LN, which is 2x plus 1. And then my bottom side is 5x minus 2. So what I actually need to do is I need to set equal 3x minus 2 and 2x plus 1. So I'm going to set 3x minus 2 equal to 2x plus 1. Because those would be the sides that connect to my vertex angle.
I did it wrong then.
You did. Because you set my the bottom side, 5x minus 2, equal to one of the other sides. Okay? Yes, I think that's what the side lengths end up being. So when you solve, you subtract 2x from both sides, you get x minus 2 equals 1. Add 2 to both sides, you get x equals 3. And then when you plug it in, 3 times 3 is 9 minus 2 is 7. 2 times 3 is 6 plus 1 is 7. And then the bottom is 5 times 3 is 15 minus 2 is 13. Yeah, so 7, 7, 13 would be the side lengths. Okay? All right, all hands on deck. You guys want to do 9 or 10? 9?
Definitely 10.
Honestly, it's the same process between the two. So it says classify the triangle based on...
10, because I don't have 10.
Okay. It says classify the triangles based on its side lengths. So what that means is I need to know the length of each one of those sides. But they don't tell me that at all. They just give me coordinates, okay? So how could I then go and find out what the side length of each one of my sides are? How do I find those side lengths? What do you think? Distance formula. So I got to do distance formula a bunch of times, okay?
Oh,
Yeah, man. I can't think of a better birthday present for you, Carter, than to forcing you to do distance formula. So I need to do distance of KP. I need to do distance of PL, and then I need to do distance of KL. All right. Very straight line there. Okay, cool. So let's do KP first. All right, so I would need to do difference in my x values, so 3 minus 5 squared, plus distance or difference in my y values. So I did 3 minus 5, so I need to do 4 minus negative 3. Got to be consistent. All right. So then let's simplify that. Square root of, okay, 3 minus 5 is negative 2. Negative 2 squared is going to be 4. And then 4 minus negative 3 is 7. 7 squared is 49. So 4 plus 49 gives me square root of 53. I don't care enough to simplify that further. It's like 7 point something, okay? All right, and then let's do PL. So now I'm working with the last two coordinates. So then I would do -1 minus 3 squared plus 1 minus 4 squared. -1 minus 3 is -4. -4 squared is going to be 16. And then 1 minus 4 is -3. -3 squared is 9. So I would get square root of 16 plus 9, so square root of 25, which is going to give me 5. Oh my gosh, a perfect square. Let's do the last one, KL. All right. Well, I know it's not going to be equilateral because two of the side lengths are different. Okay, so then K and L. So I want to do -1 minus 5 squared plus 1 minus -3 squared. -1 minus 5 is -6. -6 squared is 36. Plus 1 minus -3 is 4. 4 squared is 16. So 36 plus 16 is going to give me 52. So I get square root of 52. What can you tell me about these three side lengths?
Is it an acute scaling?
I don't know if it's acute per se, but I know it's going to be scalene because none of those side lengths are the same. So we would say it is a scalene triangle. Okay. All right, questions there? I would do 9 the same. I think when you do 9, you find that it's isosceles. I think 2 of the sides end up being the same length. So you get that it's an isosceles triangle. All right? All right, there's 4.1. You guys ready to do 4.2?
No, we're not ready.
I think 4.1 is pretty easy. Sam, what's up? Can you do it in less than 90 seconds?
Okay, I'll do it.
All right. Okay, so we're still going to work with triangles. Particularly, we're going to talk about angle sums of triangles, okay? The core of this, you guys already know pretty well. All the angles in a triangle add up to what? 180 degrees. So that's the first thing we're going to write, okay? So what we're going to work with is we're going to talk about angles in a triangle. What just happened?
I wasn't expecting to.
Wah, wah. So then all the angles in a triangle are going to add up to 180 degrees, okay? All right. So that means if I have my triangle here, the measure. I don't want to cough right into that.
I have a question.
Measure of angle A plus the measure of angle B plus the measure of angle C equals 180. Birthday, what's your question?
When do you think our test will be graded?
It's a good question. I'm mostly done with them.
Is it going?
So-
Is it going to this quarter or next quarter?
It's going in first quarter, quarter one.
What do you
Yeah.
think has it been good?
It looks really good though so far. Like when I'm,
Boost my grade a little bit if I didn't get on it.
if you did good, yeah, it should boost your grade.
No, it should
So-
make
I
it
mean,
worse.
that sounds good.
Well, yeah.
Yeah,
It should be. I don't know. I'm hoping to have it done before I leave the building. It might be a lofty goal, but I'm gonna do all that I can. So, okay. So A plus B plus C add up to equal 180 degrees. Let me show you that in real time here. All right. Full screen. Okay. So if I have a triangle, you guys already got a preview as to what is going to happen here. But if I take my blue angle and my green angle and I add it to my pink angle, let's see what happens. Boom.
That was sick.
What are you on?
Right? I know. It's the GeoGebra applet or whatever that's in the 4.2 notes. Yeah, but I don't know if you guys have ever seen that before, but if you take those angles, you will find that it forms a straight line if you add all three of those angles together. So those angles, it's not fair to say that those three angles are supplementary, but they do add up to 180 degrees. When we talk about supplementary, that's a pair, okay? All right, so really what I did there in that demonstration was they drew what's called an auxiliary line, which is a line that you can add into a diagram to help you write a proof or to prove something to be true, okay? All right, let's talk about something called third angles theorem. So in order to use third angles theorem, you need to have two triangles, okay? And if you have two triangles, if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. Jillian, you good?
Can you go back up to the top? Is it just 180?
Yeah. So if two angles of one triangle are congruent to two angles of a third triangle, or a second triangle rather, then the third angles are congruent. Okay, which would mean, like if I know that angle A is congruent to angle D, and angle B is congruent to angle E, then I can say that angle C is congruent to angle F. And if I did this in like real time to try to show that that was the case, like let's say that angle A was, 40 degrees. That would force D to also be 40 degrees. And let's say that angle B was like, 35 degrees. Then E would have to be 35 degrees. I did a really bad job drawing this. But then what would angle C have to be?
Once you take those and subtract them.
Right, so 40 plus 35 is 75. If you subtract that from 180, you'd get that's 105. Now, I did bad numbers because it doesn't look like a 105-degree angle. However, the principle would still hold true that those last sets of angles would have to be congruent to each other. I should have picked like 40 and 65 instead. It's my bad. Okay. All right. Let's talk about something called exterior angles. You guys know what exterior means. It's on the outside. So exterior angles is an angle that's formed by one side of a triangle and the extension of another side. So if I take a triangle and I extend one of the sides, the angle that's formed on the outside there is what's called our exterior angle. So then angle 1 would be an example of an exterior angle, okay? And then along with that, we have what's called a remote interior angle, okay? So remote means like not connected to. Interior is on the inside. So a remote interior angle are the interior angles of a triangle non-adjacent to a given exterior angle. All right? So for example, if I have my exterior angle as angle 1, what would be my two remote interior angles? What would be my two interior angles that are not connected to the exterior angle, angle 1? 2 and 3, good. So we would say angle 2 and angle 3. So angle 2 and angle 3, okay? So those would be my remote interior angles. Do you even have the file downloaded?
No.
Okay. Sorry, Raph. All right. Hey, so let me show you this. So I have another applet before we get into a theorem that we're going to talk about here in a second. Okay. Ready for it? Here we go. I'm going to make this full screen. So here's our exterior angle on the bottom right. And then those are the two remote interior angles. Okay? So those would be the two angles that are not connected to that exterior angle. Okay? So if I slide this, you'll see I've got that angle there. And then if I take my green angle and I rotate it, connect it to that line and slide it there, boom. Slide me. So what that means is if I add together my green angle and my pink angle, it equals my exterior angle that's on the outside there. And that's exactly what our next theorem says. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Okay? So in this picture, my exterior angle would be angle 1. My remote interior angles would be angle 2 and angle 3 because they're not connected. So we could say that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Hey, let's tap this and use this real quick. IXL practice.
Wait, can you?
You need a second?
I got it now. Yeah.
You guys have used IXL in the past, right?
I haven't used Excel in so long.
Wait, really? I just figured you guys would have used it last year.
No, I haven't used it since like 5th grade.
Wait, what? You guys been using it in grade school? I didn't know that was the case. Can I tell you something?
Was that that one bald guy?
No, that's extra math.
Yes. No, it's not.
I've never used IXL before, so you guys are gonna have to show me how to use it.
Never used this.
I've never done it.
No, yes, we have. Yes, we have. Oh my days, get out of that.
Here we go.
Oh, we have used.
All right. Yeah, I can tell you guys this is like bringing up a lot of good memories for you. So here we go.
No, it's not.
All right. Find the measure of angle 1. Okay, so we've got exterior angle here, and then I've got those two interior angles, right?
Just 100.
Yeah, so you'd add them together, right?
Is that it?
Yeah, so 32 plus 118 gives, what is it, you said 150?
Yeah.
Okay, and then what happens when I press submit?
Uh,
Fantastic!
Yeah, but get one wrong.
It gives you positive affirmations? Oh my God, that's amazing. All right, what about this one? What do I have to do?
is it the same thing?
Same thing, so add those two angles together, right? 48 plus 90 gives me, okay, turn. Keep it up! How kind is that? All right, measure of angle 1, let's see, 66 plus 75. We're getting in the groove now. You said what?
141.
I believe you. You guys are better at mental math than I
Does
am.
this still exist?
Keep it up. Oh my gosh, what great targeted practice.
Yeah, how is this not out of business?
Oh, because they're saying nice things to you. How awesome is that? That's
No,
great.
It's been so long.
Oh, it's math practice too? No. No, it is not. All right, this one's a little different though, right? Because the angle that I'm finding is inside the triangle as opposed to outside. So what should I do here?
Take away.
Take away
33.
from? Okay, so 150 minus 33 is going to give me what? 117. Ho-ho, super!
Super.
What happens if I miss it?
It's gonna say,
They'll
terrible.
tell you to.
No, it's gonna say maybe next time.
Sorry, incorrect. Oh my, they give you an explanation?
Oh,
Then you like.
What?
you did this last class.
This is
Why
not
are you
what they were
flabbergasted?
We got to do this every day.
No.
We got to do it all the time.
No, when it gives you assignments, you have to get like a certain amount.
I didn't do this. We had more time in this class. So I'm like, I'm just going to do this during this class.
No.
This is super. This is fantastic. Keep it up. Great work. Excellent. No?
Think of
All right.
another one.
Do you, what?
Think of another one.
You got this. Well done. Great job.
You
Yes,
sound
sir.
like how
Let's
a-
go.
The computer would sound.
What? It's just an AI generated voice. I write positive affirmations on the top of your quizzes and tests, right?
Positive.
I got like
At
just
my test, you
I get
wrote
that. I got the
Jillian.
same grade. as
Jillian. Yeah, like yo.
Parker.
I did. That's true. I did.
Or is there a smiley face on mine?
No,
Do you,
yeah.
I will do that for the rest of the year, no matter how good or bad you do on a test.
Parker got like 0.25 better than me on the test, and you wrote like super for him.
What I write for you?
Maybe next time.
I never have written that in my career, but I'm going to next time. For
You
sure.
write close on mine.
Close.
Close, but
You
no.
wrote nice with a smiley face.
Did I? Nice. I don't know. That's I'm not a sticker guy, so I just
Yeah, you should get stickers.
I write kind
Get the
things.
sentence spelling stickers that you
Scented smellies?
Yeah.
Yeah.
Get the millipede.
Way to bring it all back together, Mallory. All right, here we go.
Yes.
Hey, you guys tell me in letters for the first one, what's the measure of angle 2? What letters am I going to add together?
For which one?
For number 1, example 1.
What are we looking for?
I want to figure out the measure of angle 2. So I need to add together the measure of angle A plus the measure of angle C. Parker, you already told me the next one. I need to find angle 3. So what two angles am I going to add together?
A and C.
Nope, for the next one.
N and O.
Good.
Wait, how do you know this?
There are the two angles on the inside that are not connected to the outside angle. So like O and N are over here, not connected to this exterior angle right there. Let's do the last one. So I want to find angle DEF, which is my exterior angle, But this one has an expression, 3x plus 6. So I got to be a little more cognizant of what I'm doing here. 80 plus what? Equals what? Very good. So I'm going to solve for x. I would do 80 plus x equals 3x plus 6. Subtract x from both sides. 80 equals 2x plus 6. Take 6 away from both sides. 74 equals 2x. Cut that bad Larry in half and I get 37. So I know x is 37. But I need to figure out what that angle is. They said measure of angle DEF is 3x plus 6, but what should I do? Plug in 37, right?
117. Jokes.
It is 117, good job. All right, questions there? Feeling all right?
Wait.
You guys look like you want to do a proof.
How do you improve this?
Let me show you.
My feet were in this.
Okay, that theorem seems a bit like out there, like why would we put those things together? So let's do a proof of it so you guys can see where it comes from, okay? Totally copied this from a textbook. All right, so given triangle ABC with angle 1 being an exterior angle, we want to prove that the measure of angle 1, our exterior angle, equals measure of angle 2 plus the measure of angle 3. Let's do it. All right, they took care of the fun part for us. Angle 1 is an exterior angle that is given. And then it goes on to say, the statement is angle 1 plus angle 4 equals 180 degrees. And we need to give a reason. So if I look up at my picture, angle 1 and angle 4 is 180 degrees. So how do I know that? What can you tell me about angle 1 and angle 4? They are linear. So we know that if angles form a linear pair, then they're going to be supplementary to each other, add up to 180. So we're going to say that is supplements theorem. So they form a linear pair, like Alina said. So they would add up to 180 by supplements theorem. Okay. All right, the next reason is triangle angle sum theorem. What theorem is that again? Well, I have a sheet titled Try Sum Theorem. Let's see what that has to say. Triangle sum theorem. Sum of the measures of the interior angles of a triangle is 180 degrees. Okay, so what three angles would I add together to equal 180 in my picture? What three angles would I add together to equal 180 in my picture? 4, 2, and 3, right? So measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees by that theorem. Okay, so I know that 1 plus 4 equals 180, and then I know 2 plus 3 plus 4 equals 180, so what can I do with those two expressions? Set them equal to each other? Parker, stop, dude. Now, what allows me to set them equal to each other? Substitution, yeah. So substitution property. Okay. And then to go from the fourth statement to the fifth statement, it says 1 plus 4 equals 2 plus 3 plus 4. And then it says 1 equals 2 plus 3.
Subtraction.
Very good. What did they subtract from both sides? 4. Good job. So then subtraction property. Look how good you are at proofs now. All right, speaking of proofs, there's something called a corollary. I can't remember if I've dropped this word in class before. But a corollary is like a little mini theorem. It basically just is a special name given to a theorem that's easy to prove as a direct result of a theorem that you just proved. Okay? So two corollaries to talk about. First one is the acute angles of a right triangle. So if we have a right triangle like in this picture, what can you tell me about angle 1 and angle 2? The acute angles. I know this is 90, yeah? What can you tell me about angle 2 and angle 1? They add up to 90. Good. What do we call two angles that add up to 90? Yes. So the acute angles of a right triangle are complementary. Okay. Good. All right. I talked about this yesterday, and by yesterday I mean Friday. There could be at most one right or obtuse angle in a triangle. We can use that theorem to help us do this next example. So find the measures of the acute angles in the right triangle in the diagram. Okay, so it's a right triangle. I need to find what x is so I can figure out what the measure of each one of those angles are. Gotta set up an equation. What's our equation gonna look like? What do you think? 2x plus x minus 6 equals 90? Okay, that's one thing you could deal with. I like that. What's another way we could set this up? The kid in my last period class set it up differently. He said 2x plus x minus 6 plus 90 equals 180. Both of those things are equivalent. You can do either one. He just did it so he wanted to add all three of those angles together and set it equal to 180. But we did a corollary that said the two acute angles should add up to equal 90. So, all right, let's solve the way that Jillian set it up. So 2x and x is 3x minus 6 equals 90. Add 6 to both sides. 3x equals 96. Divide by 3. What do you get, birthday? I know you're plugging it into your calculator over there. That's what you're looking at on your screen.
Yeah. 32.
You're lucky you've got Parker there. What would you have done if I wouldn't have made Parker pay attention?
I would have gotten. I'm paying attention.
Okay. Oh! All right. Let's do these last examples and we'll call it a day. Yeah, go for it. All right. Hey, I like these. I look at them like puzzles. How many of you guys like doing puzzles?
I like doing puzzles.
I genuinely like doing puzzles too.
Yeah, you seem like a puzzle guy.
Big puzzle guy.
You look like the rabbit in Puzzle Bowl.
They call me the puzzler. They don't call me that. It's not like the only time I've ever done puzzles is like with my kids or like my wife and I have sat down and done a jigsaw puzzle a couple times.
The
Right?
ones that are like 30,000 pieces.
Not that
You
crazy.
haven't done the 1 million piece puzzle yet?
I've not done it yet.
So
No.
you're an amateur.
Does anybody do Sudoku? Yeah, Grandpa! Sudoku's fun too. Anyway, I kind of like these because these problems are like big puzzles. Like, look at 6. 6 is intense. There's so much going on. So what it wants us to do is we want to find the measure of each one of the angles. We got to use our knowledge of triangles in order to do that.
Can I do this right now?
Yeah, get in there.
Wait, how many
So
triangles?
basically, the first one you're gonna do.
There's a lot.
4, 74.
So what you want to start in this triangle right here, Jillian?
Hold on.
Hold on.
So that would be 63.
Okay, bring me into your world. What are you doing here? What's going on?
74 plus 43 equals 117, and then you subtract that from 180 to get.
Okay, so 74 plus 43 you said is 117. And then subtract that from 180 to get 63. And you're thinking about this as like a triangle, right? All three of those angles add up to 180 degrees. Okay, so then 1 is 63. So then from there, where do I go?
So then, after you're done with that, I actually don't know what to do after that.
That's okay. Your classmates are going to help you out.
I don't know.
Parker.
What?
What do I do next?
Then you, 1 is vertical angle 2. 2.
I didn't even think of that.
And then 63 equals 79 is 142. And then angle 3 equals
But no, wait, 132?
not necessarily.
Oh, no, sorry, 79. I couldn't read my own handwriting. I thought it said 74. Okay, cool. So then you subtract those and you get 38.
Yeah.
Yeah. Cool. So then angle 3 would have to be 38 degrees. I like it. Cool. All right, very good. Let's look at example 6. Example 6 has a lot going on in it. Okay?
Are those 3 triangles, 2 triangles, 4?
Yes.
How many are there?
There's a lot. I mean, there's 1, 2, 3, 4, and then 5, and then 6, and then 7. Like, there's a lot of triangles that are there. But honestly, you bring up a really good point, whether you meant to do it or not. Like, we don't have to use just those small triangles there. We could also look at the larger triangles and use that as well too. Okay? So there's a couple places where you can start here. I'm all ears. Where do you want to start?
At 64.
Okay. So what? This angle right here?
Yeah.
In order to start here, I would have to know, well, I'd have to, like if I started in the small triangle, I'd have to know 2 of the 3 angles. I don't know what this is up here.
No vertical ones, is there?
Womp, womp, womp. Once I find, angle 1 has a vertical angle here, right? So if I figure out what angle 1 is, then I can find that angle, which looks like can help me find angle 3. I can still kind of start there, but
2 and 1 are equal 180.
okay, I agree.
So maybe then you take.
Oh, I see.
32 and 38, is that what you said, Emma? What am I doing, Emma?
Add this together and subtract the 180.
Okay. So that gives me 70. 180 minus 70 gives me 110. So that's this angle right here is 110.
Wait, I thought I wasn't even asking you for that.
It's not. However,
That just helped you because then 2 equals 110, and then you can.
Cheering you on.
29 plus 110. Am I on something?
no, you're good. So you said 2 is 110? Because it's a vertical angle, right?
And then you add those.
Yep. Before we do that, though, let's figure out what 1 is.
Linear pair, that makes a linear pair. So
70 degrees?
how'd you get 70?
How'd you get 70?
We just went over this.
What do you mean we just went over this?
Well, the exterior,
What are you
the
doing?
interior, wait, what's it called?
Exterior angle theorem?
Yeah.
Is that what you're doing?
Yeah.
Okay. You could use that. You could do,
LGBT.
yeah, so the other way that Parker was thinking about it, and you guys might have just said this exact same thing, but if you add together 32 and 38, that'll give you the exterior angle, which is right here, which is 70 degrees. Is that what you guys were talking about up there? That's another way you could do it too.
Yeah, that's what we were talking about.
And then the one across from 70 is 70.
True?
And then you take 64 plus 70 and take that and subtract that from 180.
114? No, that's not right. 134.
134.
134.
Sorry, math is hard. Okay, so then I know that this would be, take that away from 180, right? 46. Sorry, my handwriting is a little bit sloppy. Oh, yeah.
46 was 32.
Boom. And then what?
70.
Work with this for 180, right?
104 equals 102.
All 3 of these angles here, here, and here add up to equal 180, and you know 2 of the 3.
I didn't know there was one.
37. 5 equals 37.
So 32 and 46 equals 78. 180 minus 78 is 102. So measure of angle 4 equals 102. Okay. So that's 102. And then can't we find angle 5 after that pretty easily? 41 plus 102 equals 143. 180 minus 143 equals 37. So then measure of angle 5 is 37 degrees. Bravo. All right. How are we feeling? We okay? Una más. Example 7. Hey, this one's got a special little treat in there, though.
They're parallel.
They're parallel. So I can use what I learned last chapter to help me answer these.
Opa.
I don't remember.
Okay. If I have lines that are parallel cut by a transversal,
Does the 135 and 1 equal 180?
They do. So what would angle 1 be?
180 minus 135, which would be
No. What?
45.
45?
Yeah.
Okay.
And then once you have that,
Once you have that, you can find another angle really easily.
2,
Eh,
3,
eh.
5, because they're alternate. Interior.
Ugh, slam dunk. So this would be 45. Alternate interior angles because lines are parallel.
And then you can find
Nice assist from Molly there. I like it. Where are we going from there?
4. Would that be also be 45?
Mm,
No, 3.
mm,
That is not alternate.
mm. I could find angle 3 pretty easily though. What is angle 3?
60.
Ooh, same logic, right?
Yeah.
Okay. That leaves angle 2 and angle 4.
Alright, so then to get to 60 and 45, those ones would be 180s. And you do 45 plus 60 and subtract. Yeah, that's what I was going to say.
So 75? Cool.
I was on my way there. It's all right.
All right, 4 should be easy. 3 is 60.
Wrong tracks.
So 4 would be
120. I mean, yeah.
good job.
That one really hurt.
Hey, good job, guys. Good job, team. Well done. See, wasn't that thrilling? Like, so thrilling.
It was so fun that we shouldn't have them.
Yep. All right, I've got to crack down a little bit on you guys using your iPad in class for things other than math. Bryce and everyone else. Not everyone else, but
YouTube games.
there are some people doing things. So, here's what I'm going to have to do. I'm going to have to keep my screen up that keeps tabs of what you guys are doing on your iPad.
What are you talking
Which means a
about?
couple of other things.
Apple class, that.
Dude, I like
After
the-
class,
I like
right?
Oh,
that
that's
problem.
like not even that bad. I think that with the thing that
Why don't you just start grading the notes?
Yeah,
No, that's dumb.
no, like every once
It's
in a
like
while.
getting a reward for doing something you're supposed to be doing.
That's
Exactly.
funny.
Listen, I don't necessarily
That's
care.
how grades work, yeah. You're getting graded on something that you're supposed to do.
I don't necessarily care if you guys take notes. That is up to you. However, like,
Facts.
what I do care is I don't want you in class, like, you know,
Dilly-dallying.
playing games or watching film or messaging friends or whatever you guys do on your iPads now. Also, you got to make sure that this is your own device, not from home, but from school. Can't bring your home iPad with you either.
Who has their home iPad?
People think they're
Zoe.
Zoe does.
Do you have you? Have you?
Huh? I don't know that
Oh,
person.
no.
But my daughter did dress as Zoe for Halloween
Who's Zoe?
from the K-pop
Oh,
team.
okay.
If I see one more K-pop demon.
It's
Girl,
my
you're
kid's
wearing
birthday.
the tiniest.
When we went trick-or-treating, I put the demon marks on me.
Mr. P, what'd you dress up for?
I put the demon marks on me. That was the demon.
The rabbit? The rabbit. You
The rabbit.
dressed up as
I had bunny
Easter
ears.
Bunny?
Yeah.
No, why?
Evens or odds? What do you guys want to do? Evens or odds?
Odds.
Odds. Do the odds.